everybody again. Today we're going to be learning about congruent triangles. So let's start. Triangles are congruent to each other if the following conditions are true. Two sides and the included angle, this is the angle that sits between the two given sides, are equal. This is remembered as SAS, side, angle, side. There are three pairs of equal sides. Remember this as SSS, side, side, side. Two angles and the included side. The included side is the side that is placed between the two angles are equal. Remember this as ASA. If you have right-angled triangles, the angle does not need to be included for the triangles to be congruent. The triangles must have the same length of hypotenuse and one other side equal. Remember this as RHS, right angle side hypotenuse. I think it's a typo and it's supposed to be RSH. Yeah, RSH. If any one of these conditions is satisfied, then you have two congruent triangles. Work example 16. For each of the following pairs of triangles, show that they are congruent. So, length PQ equals length ST, and angle PQR equals angle STV, length QR equals length CV. So, the condition is SAS and the triangles are congruent. Here, the condition is SSS and the triangles are congruent. Here, the condition is ASA and the triangles are congruent. And here, the condition is ASA, so the triangles are congruent. So, exercise 11.8. For each question, show that the pair of shapes are congruent to another. Explain each answer carefully and state clearly which of SAS, SSS, ASA, or RHS you have used. Again, this is supposed to be RS8. So, here, these are congruent because SSS. Here, these are congruent because ASA is satisfied. Here, this is congruent because RSH is satisfied. Here, the triangles are congruent. Here the triangles are congruent because SSS is satisfied. Here the triangles are congruent because SAS is satisfied. Here the triangles are congruent because RSH is satisfied. Or maybe ASA. Both are the same. Here, both of the triangles are congruent because SAS is satisfied. And here, both of the triangles are congruent because RSH is satisfied. Here. In a figure, PR equals SU and RTUQ is a kite. Prove the triangle PQR is congruent to triangle SQU. So, here, triangle PQR is congruent to triangle SQU. Well, let's see. Because this is a kite, first of all, PR equals SU. So this side is the same. This angle is the same because they share the same angle. And because this is a kite, this side is the same. These sides. So it is congruent because SAS, side, angle side. Question 10. In a diagram, AM equals BM and PM equals QM. Prove that AP equals QB. So AM equals BM and PM equals QM. Prove that AP equals QB. Well, here, these two angles are equal because they are angles on the opposite. Okay. And since AM equals BM and PM equals QM, these sides are the same and these sides are the same. These angles are the same, so AB equals QB. So it means these triangles are congruent because A is A. And since these are the opposite of each other, which means AP equals QB. So, two airstrips, PQ and MN bisect each other at O, as shown in the diagram. So here, just draw a line between PN and MQ. PM and NQ. Here, you can see these two angles are equal, and because these bisect each other, then these two sides are equal. These two sides are also equal, so SAS, these triangles are congruent, which means PM equals NQ. Yes, and that also means PN equals MQ. Question 12. Triangle FAB is congruent to triangle FED. Prove that BFDC is a kite. So, since triangle FAB and FED are congruent, angle FAB and angle equals angle FED. And that makes triangle CAE a right angle isosceles triangle. Yep. And the next part is that it follows that AC equals AC minus BC equals BC. No. So BC equals CD, right? So BF equals DF, which means therefore BFCD is a kite. Two pairs of adjacent equal sides. So that's the end of this video. Oh wait, no. Silly me. Don't click off this video. No. Don't you dare. Summary. Do you know the following? The longest side of a right angle triangle is called the hypotenuse. The square of the hypotenuse is equal to the sum of the squares of the two shorter sides of the triangle. Similar shapes have equal corresponding angles, and the ratios of corresponding sides are equal. If shapes are similar and the lengths of one shape are multiplied by a scale factor of n, then the areas are multiplied by a scale factor of n squared, and the volumes are multiplied by a scale factor of n cubed. Congruent shapes are exactly equal to each other. There are four sets of conditions that can be used to test for congruency in triangles. If one set of conditions is true, the triangles are congruent. Are you able to use Pythagoras' theorem to find an unknown side of a right angle triangle? Use Pythagoras' theorem to solve real-life problems. Decide whether or not two objects are mathematically similar. Use the fact that two objects are similar to calculate unknown lengths, areas, or volumes. Decide whether or not two shapes are congruent, and test for congruency in triangles. So, this is the end of the video. Thank you and goodbye. Now you can click off the video. And please click on another video of mine. Please, and subscribe.